Hello. We're going to work some problems on differential equations, the first introduction to them. And you're ready for it. You can do derivatives, and now you're starting to do integrals. So we're going to put the two of those concepts together and show you that you can do some beginning differential equations. For example, on your handout, problem number 1 is given like this. And it says dy dx is equal to 3x cubed minus 1 over x. And our goal is to find out what y is. So the first thing we're going to do is multiply both sides of the equation by dx. This is called separation of variables. Now, since we want to get y, the best way to do that would be to integrate. Right now, it's in differentiation form. So if we integrate, we're going to undo that differentiation. And now you see that the integral of the derivative is just y. And then we have to integrate over here with respect to x. And I like using the parentheses when I bring the dx over and multiply. And then I leave it in because everything has to be integrated with respect to x. So we're going to copy our constant multiplier. We're going to use reverse power rule. X cubed is going to become x to the 4th over 4. And then this one you just have to remember. If you differentiated a natural log of x, you would get 1 over x. So integrals or antiderivatives will take you back. So they're at minus natural log of x plus c. And on some of the other problems we're going to do, we will be able to solve for c, but now we just write it to say there could have been a variable, or excuse me, a constant there, we don't know what it was. So there you did it, your first differential equation. You're ready for the whole class pretty soon. Problem number 3 on the sheet gives you some information that will enable us to solve for c. So let's try that one out. We're going to follow the same steps we did last time. First, multiply both sides by the dr on the bottom, or dx, or whatever. And dy is in the numerator, and we want to get it on the left side of the equation, and all the right side will have will be r's. So quantity minus r squared plus 2 times dr. And now we're going to integrate both sides. And just like last time, knowing that the integral of the derivative is undo process, or reverse process, we're going to be left with y. And we'll integrate with reverse power rule on the right, minus r cubed over 3 plus 2r plus c. But this time, we have a little bit of information that will help us solve for c. This little bit says y of 2 equals 3 means that when you plug a 2 into the function, you're going to get an output of 3. So we're going to write 3 equals minus our input 2 cubed over 3 plus 2 times input again, 2 plus c. Now we'll clean it up just a bit. So that's 3 equals minus 8/3 plus 4 plus c. I think I'm running out of space, so I'm going to go sideways here. So c must equal, that's not a very good looking c. Let's see, if we got everything to the left side, we have a minus 1 and minus 8/3, so that would be minus 11/3. And in place of c up in this line, we're going to finish it off, clean it up with minus 11/3. So y is now equal to minus r cubed over 3 plus 2r plus a negative 11/3. And that's your equation for y. So finishing off that last problem, we had given that we have an input of 2, the output is 3. So every place we see an r, we're going to put a 2. So minus 2 cubed became minus 8/3. 2 times 2 became 4, and c is just left. We're going to solve for c. And all of this is equal to 3. So let's do a little bit of rewriting. Let's leave c alone on this side. Actually, I sort of mirror flip this. And put all the numbers together on the other side. So we'd have a positive 3, subtract a 4, and you'd have to add an 8/3 to both sides to get it on the other side where I want it. And combining things, 3 minus 4 gives us a minus 1. But we've got to deal with fractions, so let's call that minus 3/3 instead. Combining with positive 8/3 will leave us 5/3. So now I can write my equation for y as y equals minus r cubed over 3 plus 2r plus 5/3. Thank you. So back to the problem, integration visually. And on your handout should have some nice clean grid lines so that you can actually compute these. And I've done a pretty crummy job of sketching it here. And I'm still going to try to count blocks because in introducing integration, which sums things up, we can start to understand integration by visually seeing the accumulation of area as we move across the function. So this is our function f of x, and it has traced out some area above and below the x-axis. And remember that integration can be looked at as finding antiderivative or as summing up rates of change and areas and volumes. We're going to look at this one as summing up areas, and this approach to integration. They're all the same, but it can be viewed two ways to base your understanding. So this time integration visually, we're going to try to find the integral from 0 to 2 of our function f of x with respect to x. So we look at our graph and try to determine how much area has been accumulated by the time we go to 2 after starting at 0. And I'm looking at the blocks being 1 by 1 blocks, therefore each block has an area of 1. So the little half blocks must have an area of 1/2. And so I'm going to put that together and get 2.